All right, guys. I have a quick 2026 JAM examination question. Okay, this is a likely question this year in the UTME exercise, and it's a very simple question about the energy profile diagram. Okay, and of a reaction. Okay, it's a reaction coordinate. Okay, now the question says in this diagram, Z in the above diagram represents what? Now, this is actually an energy profile diagram. How do you know it's an energy profile diagram? It's usually plotted the energy against reaction coordinates. Okay, so energy against reaction coordinates. Now, and A plus B, so there'll be two ends in the reactions, in the graph, pardon me, in the curve. So the curve is going to start somewhere here and end somewhere here. So this part is the product, this part is the reactant. So anytime, this is energy. So anytime the energy, so if we trace this now, okay, if you trace this something like this, so anytime the energy of the product is higher than that of the reactant, anytime the energy of the product is higher than that of the reaction is said to be endothermic. So just take note of that. Once the energy of the product, once the product is higher than the reactant, is endothermic. While anytime the reactant is higher than the product, the reaction is exothermic. Okay, because delta H is going to be negative. So anytime the reactant is higher than the product, exothermic, that means if you have this kind of curve again and you have something like this, okay, please just pay attention, and you have something like this. So you can see that the reactant is higher than the product. So this is for exothermic, and this coordinate is for endothermic. So they're asking us what is Z, okay? And the Z is actually different between this and this. So it's more like Z is different with this is also Z. Okay, this is also Z. Pardon that the line is bent kind of, but just this is also Z. So it shows that Z is actually the difference between product and reactant. And the difference between product and reactant, between energy or heat of product and heat of reactant, is known as the enthalpy of the reaction. So that's called enthalpy, or we call it heat of reaction. So Z is enthalpy of reaction, or we call it heat of reaction. So what is Y? What is Y? Okay, why does not really have a given value, why does not really have a given name per se, but I will tell you what I can relate Y and Z together. Now please watch. Now quickly, the peak of the curve, this X, the peak of the curve, this curve here is called the activated complex. That should be taken note of. So that should be taken. It's called the activated complex. So in case you are asked, X is activated complex. Activated complex is usually energy plus energy plus reactant. So this is going to give us product. So it's called activated complex. Activated complex. Activated complex. Now quickly, the distance between the activated complex and the reactant. Distance between the activated complex and the reactant. Distance between the activated complex and the reactant is known as activation energy. So in this particular curve, activation energy, let me write it here. In this particular curve, activation energy for this particular curve. So activation energy is the energy required to break energy barrier in the reactant for the reaction to start up. Or we call the minimum amount of energy reactant particles must possess to start up the chemical reaction. So for this reaction, activation energy is going to be Y plus Z. So Y does not really have a given value. So activation energy is going to be this. So activation energy is like the distance between this place to the activated complex. So this is the energy from the reactant to the activated complex. So in this case, it is Y plus Z. So in some curve, they can just give you as X. Once just give you straight as X. So you can be asked. So with that, we'll come to the end of this video, and I hope you understand it. And for now, more of this will be coming your way. If you like the video, please make sure you subscribe, you hit the subscribe button, and like this video, share it with your friends. More updates, share it for those of us who are writing the UTME examination this year. See you.